Hello, this is Paul from Foresight Tech. In this lecture, I will going to introduce the precise definition of a limit, and we call the Epsilon-Delta definition. In 2.2 before, we introduced the intuitive definition of a limit, right? Isaac Newton proposed the intuitive definition of limit a long time ago, more than 350 years ago. And then use the limit definition, and Isaac Newton built the foundation, built the calculus, which was very popular. However, we know that's not solid. Okay, the foundation is not very solid because the definition is not strict in mathematics. So it's just an intuitive way. And until 100 years later, okay, and after Isaac Newton proposed the limit and the calculus, about 100 years later, another French mathematician, so we call it Cauchy. Let me show you. Is this one, okay, who is very, very famous, okay, in the mathematical history. So we call it Cauchy, and proposed the Epsilon-Delta definition of the limit. And from there on, the foundation of calculus is very solid in mathematics. So in this lecture, we're going to introduce what is the Epsilon-Delta definition. And this one is super important, okay, in the history of calculus. And however, probably a little bit challenge for you the first time. If you are the first time to learn this language, we call the Epsilon-Delta language, because everything we deal with is proof. The proof is the foundation of mathematics. Mathematics always we call it is proof. Okay, so we will prove all the most important theories in this calculus class using Epsilon-Delta definition. So everyone, please pay attention to this definition. And so first, let me going to see what is the definition of Epsilon-Delta. Okay, for a limit. So here is a limit. The limit is L. Do you remember what is the intuitive definition? The limit equals L means this. As x approach A, f approach to L, right? Or we say we can make f arbitrarily close to L by taking x sufficiently close to A. What does that mean? Really mean in mathematics? So here is the way. Okay, so let me read this first, and then I will explain this later. For every epsilon and greater than 0, there exists delta greater than 0. Epsilon is here, epsilon, and delta are ancient Greek letters. Okay, ancient Greek letters. We were using this, we call it Epsilon-Delta definition, such that if the distance between x and A is greater than 0 and less than delta, then we have the difference between f and L less than epsilon. What does this really mean? Okay, so first let's look at what does this mean. And this means x close to A, right? Because what? Because x minus A is less than a number. This we call it the radius. Okay, and y is greater than 0, not equal 0, because we want to exclude the A itself from the definition. Do you remember? When we're talking about the limit, we never consider x equals A, right? We don't need to consider that point. So we exclude x equals A, therefore this is greater than 0, not equal. The second, what does this mean? F minus A absolute value less than epsilon, which means the distance between f less than epsilon. Okay, because epsilon is any number, every number, whatever how many small epsilon is, and the f minus L always less than epsilon, which means f is close. Okay, close to L arbitrarily. Okay, as we said before in the intuitive definition. So if we put everything together, because of the arbitrary epsilon, see, we say what f can take arbitrarily close to L by taking X sufficiently close to A. That's exactly consistent with the intuitive definition, right? Okay, let me explain another way, which is more important than this. Okay, we use the neighborhood to describe this. What does it mean? And here, F close to L, we call it is the neighborhood. Okay, what does this mean? Means the distance the distance between F and L less than epsilon is exactly, we call it the epsilon neighborhood of L, or the value of F goes to the epsilon F1. So here is we call the epsilon neighborhood of L. Okay, F can go into the epsilon neighborhood of L. Okay, which means arbitrarily close. By taking X sufficiently close to A, okay, we use the neighborhood each, which means if X go into the neighborhood of the delta neighborhood of A, of course we exclude X equals A. And what does it put together? If X go into the delta neighborhood of X and F go into the epsilon neighborhood of L, okay, this we call the epsilon delta language. A little bit abstract. Because of the arbitral epsilon, we know F is arbitrarily close, which means the limit, right? And let us see, okay, see this definition in the graph. In the general graph, here is the general graph. If this is the domain, this is the range, and the F is a mapping from the domain to the range. And what does the limit equals L mean? Do you remember? F were arbitrarily close to L if we use the neighborhood. Is see, this is the center, and the radius is epsilon. So this is epsilon plus this is L plus epsilon. This is L minus epsilon. Okay, which means if F arbitrarily close to L given epsilon, F can go into the epsilon neighborhood of L by taking X sufficiently close to A, which means exist. We can find the delta, so that if X go into the delta neighborhood of A, see that the center delta is the radius. Okay, so we have an open interval. When X go into this neighborhood, and all the F will go into the epsilon neighborhood of L. That's what the definition tells us. Okay. So, how to prove? Does this make sense? Okay, you can imagine why, given any epsilon, F can go to the epsilon delta neighborhood when X is going to the delta neighborhood of A. Why did it say the limit equals A? Because of the epsilon. Because the epsilon is every number, no matter how small it is, F can always go into the neighborhood of L. The epsilon neighborhood means F can be arbitrarily close to L, okay, by taking X sufficiently close to A. You know exactly is the definition, consistent with the intuitive definition. Okay, so how to prove? And if we have the epsilon delta language, how to prove a limit is L? Okay, here is the one. All we need to do is like this. Any epsilon given means we have a number epsilon. All we need to do, so can we make F into the epsilon neighborhood? By find the neighborhood, delta neighborhood of A. When X is going to the delta neighborhood of A, F go into the epsilon neighborhood of L. So we need to find the delta. That's the most important. So we find the delta greater than 0, so such that this statement is true. What is this statement? This statement, which means if X go, this means if X go into the delta neighborhood of A, see, go into the delta neighborhood of A, of course exclude A, and then F going to, see here, F going into the epsilon neighborhood of L. F go into the epsilon neighborhood of L. And F mapping all these going to here. Okay, what does that mean? Means f can arbitrarily close to L. Okay, by taking x sufficiently closer to A. All we need to do is find the data. And this is the one. Let me show one more graph. This is the general graph. We use the mapping. And if we know the graph, if I draw graph, you will see it clearly. See if you can look at this graph. If we draw xy Cartesian system, if we have a graph of the function, and the A is at here, and the L is at there, what does it mean? The limit of f is L. Okay, you can imagine what we say. Given any epsilon, no matter how small, and we can find that the epsilon neighborhood of L, which means this open interval on the y-axis, right? F can go into this epsilon neighborhood if, do you remember? If we can find, okay, if, and exactly we can find the data. If x going to the data neighborhood of A, exclude A. If x going to the data neighborhood of A, can you see? Going to, when x is going to this, what is the y value? Or the y value is already going to the epsilon neighborhood of L. That's the epsilon data language, right? So from this graph, any epsilon given, we can find the data when x is going to the data neighborhood, or the y value going to the epsilon neighborhood of L, which means the limit is L. Okay. Let me show you one more. And this is an example. And later I have a few examples show you. Okay. Can we look at the graph? Can we look at this point? This point is defined somewhere. Okay. We have a jump. But don't worry, okay? And we know the limits of f as x approaches 3 is equals 5. Why is equals 5? Equal 5 does not depends on the definition on x equals 3, right? Okay, so what is the function? The function is here, okay? And when x equals 3, it's jump to 6. When x does not equals 3 is 2x minus 1, which means a straight line. There's a 9 equation, okay? And can we say, and this graph is already tell us the limit equals 5 because of the intuitive definition. See, no matter x is approach to 3 from the left or from the right, and the y value always approach 5, right? So we know this is true. But how about the epsilon data language? So we need to think about the epsilon data language. Epsilon data language is this, okay? Given any epsilon, okay, no matter how small, and we find the epsilon neighborhood of 5, can we make all the f go into this epsilon neighborhood of 5? That's what we need to do, right? Yes, we can. We can find the data, okay? And then we can find the data. So data is here. Of course, y is this. We can find a data equals half of epsilon. Okay, when all the x go into the data neighborhood of 3, can you see? All the y value is going to here is going to the epsilon neighborhood of 5, right? Okay, so which means if you find it, that's true. Now the questions, how to find the data? So I give you a little bit intuitive. So how to find data? Because we have epsilon, so we have 5 minus epsilon, draw a horizontal line, we get a point, and then draw a vertical line, we get another point. Of course, we can find the value of this point, which is, we define this as 3 minus epsilon. You solve, you will find the data is epsilon over 2, okay? So the same, or if you draw a horizontal line at 5 plus epsilon, y equals, find this point, draw a vertical, you can find it. It's the same, okay? Because of the symmetry, you can find the data is equals epsilon over 2. And this is the explanation, of course. And in general questions, we will not use this graph method to find the data, okay? So we will have a technique. How do you find the data? Whatever we need to do is find the data, right? Given epsilon, find the data. When the x is going to the data neighborhood of A, the y value go into the epsilon neighborhood of L, and therefore we prove the limit is L. Okay, that's all we need to do. I have I have three questions to show how to do this technique. So how to using Epsilon-Delta definition to prove the limit. To prove the limit equals L, and the major one is find the delta. So three questions are different, so please keep in mind. So how to find the delta? We have a basic way. It's not so complicated. So let me show. Do you remember the definition? So the definition is given epsilon, we need to do what? We need to find the delta. At the beginning, we don't know what is delta. So we need to do what? We need to find the delta. Usually, we separate the steps into two. The first step, find, or explore something, explore data, or find the data on a scrap paper, another paper. The second step, we wrote down all the steps. So can we see here is all we need to do. So I will going to find the data on another paper. After we find the data, and then I copy everything on the paper. Write all the stuffs down. What do we need to do? This is the definition, right? Given epsilon, we need to find the data. We don't know what is data. If you find the data, usually data is depends on epsilon. Such that this is such that. Such that. You know, and this is simplification for such that if x is going to the delta neighborhood of A, can you see, f going to the epsilon neighborhood of L. That is the neighborhood language, epsilon delta language. We need to find this. So in these questions, what is A first? Let me see. A is 3, right? So first we get A should be equal to 3. And the L is 7, F is these linear functions. Can you see how to find the delta? The basic technique is this. Resolve. The basic one is this. All the question we need to do, all we need to do is find the delta. But how? Usually we could this. I highlight. Resolve this is inequality. Try to explore this inequality and then resolve for delta. So this is the basic technique. So I will show you this example how to do. So let me go on to see what is F is there, right? All we need to do is just so we need to find the F. So I put here. Is Fx is that is 4x minus 5, right? This is F minus L is 7. The distance, this is the distance, less than epsilon. So of course we need to simplify. So our going to simplify is what we get. We get a 4x minus 12, right? One more 4, we can factor out. We factored out what we get. We get x minus 3. That's good. X minus 3. Can you see x minus a less than delta? Delta is linked to x minus 3. Definitely we have x minus 3 here. This is important. So now all we need to do is do this. We set up this equals epsilon. Why we set up this equals epsilon? Another equals epsilon. Let me show. I will write one more step. I wrote one more step because x minus 3 is less than delta. So I will write one more step. So this will less than 4 times delta, and then we set up this equals. We set up this equals epsilon. Why? If we set up this equals epsilon, we can solve for delta. That's what we need. And the second, if we set up this equals epsilon, can you see? And this, the left is equal to this, less than epsilon. Definitely we can find it, right? Or let me see. This is the first, the very basic technique we need to do is solve this, explore this inequality. We already gone to here, and then we set up equation. Let me see this equation. Easy to solve. After we solve, we find that delta equals epsilon over 4. Okay, can we find? This is the one we need. If we set up delta equals epsilon over 4, we can find that the distance is less than epsilon, which means this is true. Okay, have we find the delta? Yes, we found. You can see delta is linked to epsilon. Don't worry, epsilon is just a number, any number that is given. Okay, so now the second step, we need to write all this step down on the paper. Okay, the second step is write down all the stuffs. Write down all the stuffs, we usually have a basic way. Okay, so here is the basic way to write your stuff clear. So all we need to do is do this. Is given any epsilon greater than 0. Okay, and we need to find the delta. Have we found? Yes. So I can write down, choose delta equals how many? Okay, let me see. We already find that delta equals epsilon over 4 because epsilon is given, so delta equals epsilon over 4. This is a number. Okay, don't worry, it's a number. This is the most important step. Okay, we already find. Do you remember the definition? If we find this, all we need to do is make the statement true. What the statement? If x is going to the delta neighborhood of 3, and the function, the value of the function going to the epsilon neighborhood of 7, we write down that stuff. Okay, can we see? Now that stuff is true because we based on that to find the delta. Okay, so here is if 0 less than x minus 3 less than delta. You know what that is mean? This means x is going to the delta neighborhood of 3. Okay, x is going to the delta neighborhood of 3. Of course, we exclude x equals 3. Okay, then does the value of the function going to epsilon, the epsilon neighborhood of 7? All we need to do is make it so that's true. Okay, is this 4x minus 5 is the function minus 7. Okay, we find this and do calculation. All we need to do is copy what we wrote, right? The first 4x minus 12, and then we factor the 4 out. We get 4 times x minus 3. Can you see? Do you remember this? Because x minus 3 less than delta. Okay, so this we can see this is less than 4 times delta because this is less than delta, right? And then what is delta? Delta we already pick. So I plug delta in here. See what do we get? Is 4 times epsilon over 4. Do calculation. What do we get? Okay, we get epsilon. That's true. So look at this statement. This statement tells us what? If x is going into the delta neighborhood of 3, and the value of the function going into the epsilon neighborhood of 7, that's epsilon delta definition of the limit. Does this make sense? Okay, now we can based on the definition, so we make a conclusion. So by epsilon delta definition, and we have the limit is 7, right? We have the limit as x approach 3. Okay, the function is 4x minus 5 equals how many? Equals 7. And did the first proof, epsilon delta proof for you. And does this make sense? Okay, 2 steps. Can we see? Go over a little, because all the proof is just like this. Okay, the first step, based on the definition, we need to find the data on another paper. Okay, by what? By solving this inequality or explore this inequality. After you find it, and then to write down all the steps. Okay, just follow this basic way. And then one more questions. Okay, this is the second. And then you will see, and in these questions we will have a little bit different from the first. Okay, and the first is easier than this. Okay, a little bit of challenge. And however, I will show you what's the technique. Okay, what is the technique we need to find? Still going to find the delta, and this time we have delta 1, delta 2, and then we're going to make delta is the minimum between delta 1 and delta 2. Okay, this is a very important technique you need to know. Let me see. So the first step is the same, right? The first step is still the same. All we need to do is find the delta on another paper. So I'm already right here. This is the definition. Given epsilon, you need to find the delta such that if x go into the delta neighborhood of A and f, then f will go into the epsilon neighborhood of L. Okay, the definition. Epsilon, delta, language. Okay, so what is A in our questions? It's 3. Okay. A equals 3. Good. And we need to find this. You know how to find it. And from solving, right? Explore this or solving this, but this time of solving we have a little bit different. Okay, all we need to do is solving, explore this inequality, and to find the delta. What is L? L is 9. What is F? X squared. Okay, so let me write down this. And F, explore this. Okay, explore this. Go from this always. Is this x squared per, not plus, sorry, x squared minus 9. X squared is f minus 9. Okay, absolute value. This is less than epsilon. Of course, what do we need to do? Keep in mind, is same as the first questions. All we need to do is link this inequality to what? To delta. How to link? You need to find the term x minus 3. How to find the x minus 3? Okay, factor, right? So factor, this is the difference of squares. The difference of squares, I factor, I get x plus 3 times x minus 3. You know how to factor, right? Okay, this time we have x minus 3 linked to delta. Very good. But unfortunately, we have 2 terms. Okay, if we only have 1 term, it's easy. Okay, just less than or whatever, and solve as the first example I showed you. But how to deal with these 2 terms? Okay, we have to do this. We have to control the first term and the second term at the same time. Therefore, from the first term, later we will have delta 1. From his, we have delta 2. And then we make, okay, delta is the minimum of delta 1 and delta 2. This is a very important technique. So how to do that? Do you remember? See, and x support 3, which means what? We take x sufficiently close to 3. We can control x plus 3. X plus 3 should be less than, like less than 7, less than 10. Can we do that? Can we control this less than? I will going to make a easy one. Less than 7. Okay, I will going to control this term first. I say this term will less than 7. Why this less than 7? Because x support 3. You can, let me see this. I draw a graph so you can see x support 3. If I put the 3 here, and I can make a delta. So can you see this? X minus 3 less than delta. I make a delta 1. Is 1. Okay, I pick a 1. I pick a 1. And the delta 1 equals 1. So delta 1 equals 1, which means I will look at the neighbor. Okay, the 1, the neighborhood of 1 of 3. So can we find this point? This is 4, right? What this point? This is 2, which means if I pick delta 1 equals 1, okay, when x is going to this neighborhood, all the x were less than 4. Can we see this? All the x were less than 4. Easy. All the x less than 4, so x plus 7 less than 7. That doesn't make sense. Okay, so when x is going to the first neighborhood, we know the first term can be controlled by 7. Okay, separated. Now we look at the second term. Okay, I mean the first term we already have. If I wrote something here, the first term delta 1 equals 1. Okay, how about the second term? The second term is easy. Okay, our purpose is to make what? Is to make 7 later times this term less than epsilon. I can easily to pick. You imagine, I pick delta 2 equals epsilon over 7. What does it mean? If x minus 7 less than delta 2, which means less than epsilon over 7, can you see the second term less than epsilon over 7? Okay, if we pick delta 2 this, when x is going to the delta 2's neighborhood of 3, the second term less than epsilon over 7. Why we pick this? Because when we pick this, the first term times the second term goes to epsilon. Okay, of course, delta 1, delta 2, how to merge these two together. This is important. Okay, imagine the first term less than 7. If x is going to the delta 1's neighborhood of 3, okay, the second term less than epsilon over 7. If x is going to the delta 2's neighborhood of 3, how to make both true at the same time? Make the smallest delta. If we pick the smallest delta, both the first term and the second term control by what we did. Okay, so here is the one. We need to do this. We need to do I put it here. So delta equals the minimum. This is the technique you need. Delta 1 and the delta 2. Okay, I pick this. If I pick delta equal this, the minimum, and when x is going to the delta neighborhood, okay, of 3, the first term less than 7, the second term less than this, and can you see now what do we have? This is less than 7, the first term 7 epsilon over 7, the second term was the result epsilon, which means what? If we pick this and this is true, that's the one we need. Okay, that does make sense to you? And for a lot of questions, we need to find the delta 1 for one part, find the delta 2 for another part. How to pick? And usually we pick the minimum of delta 1 and the delta 2. In that case, both control is true. Okay, so we finally will make less than epsilon. And I hope this makes sense to you. And then now all we need to do the second step. What do you do? Write down all the steps. Okay, write down. What is delta? We already find, right? So delta 1 is 1. Delta 2 is epsilon over 7. Okay, so I put it here. The first step is explore everything on another paper. Okay, after we find the data, this is a little bit complicated. After we find the data and then make the stuff. Okay, write down all the stuff as the first questions we did. So now all we need to do is do this. Now is not difficult. Okay, if we already get it. So now is just write down given epsilon greater than 0. Choose, right? Remember that. You have to choose. Okay, I'm going to choose delta equals. Do you remember? See, this is the minimum of delta 1 is 1. Delta 2 is epsilon over 7. Yes, epsilon over 7. See, this is the most important. So we find. How did we get this? We explore that inequality on a paper, right? See, the minimum of 1 and epsilon over 7. 1 and epsilon over 7. Good. Now we make the statement. If x is going to the delta neighborhood of 3, see if y goes to the epsilon neighborhood of 9. Yes, that's definitely true, because we did. Okay, we just write down. So it is, if x is going to the neighborhood of 3, which means this, x minus 3 greater than 0. Greater than 0, which means we exclude the x equal 3, right? And less than delta. So this means x go into the delta neighborhood of 3, exclude the 3. And then if y going to the epsilon neighborhood of 9, so we're going to make, so it is fx, right? And minus 9. See, fx minus 9 is less than epsilon y, as I just copy what we did. The first step, break down factor, right? So we have x plus 3 times x minus 3. Do you remember this? Okay, so we just get it because delta is less than 1, less than or equal to 1, which means x minus 3 is less than 1. This is less than 1, remember this? The first term less than 7, since x is less than 4. Do you remember this? X less than 4 is less than 7. The second term, okay, now I will put it here. So this is less than, the first term less than 7. Good. How about the second term? Second term less than delta. I just copy. Okay. And then what is delta? Delta is less than epsilon over 7, right? Or less than or equal to. Okay, good. Less than or equal to 7 per times delta. The second delta, you say, okay, is epsilon over 7. Of course, now do the calculation. We get epsilon. This is d1. And you see, if x is going to the delta neighborhood of 3, y going to the epsilon neighborhood of 9. This is epsilon delta language, okay, which means what? F can arbitrarily close to 9, less than any epsilon. Good. That's the epsilon delta language. Now all we need to do is by the epsilon delta definition, we wrote down the conclusion. So by epsilon delta definition, right? Okay. Definition. We have the results. The limit is 9. Okay. The limit as x approach 3. So you go to the delta neighborhood of 3. So it's 3. And the function is x squared equals 9 there, L. This is the proof for the second. This is a very, very important technique. Okay. So if we have more than one term, you are going to see, if we have more than one term, usually we will find the delta 1, delta 2. If we have 3 terms, we'll find the delta 1, delta 2, and the delta 3. And then we're going to choose the minimum between delta 1, delta 2, delta 3. Here is delta 1 and the delta 2. So we're going to pick delta is the minimum between delta 1 and the delta 2. Keep in mind, this is important. And I have another questions. We still have to choose this. Okay. So we're going to practice one more questions. How to pick the minimum of delta 1 and the delta 2. Okay. And we see. Here is the questions. That's the law of limit, right? The sum law. So we learned the last time. If f has limit L, g has limit M, so the sum of the limit equals the limit of the sum equals the sum of the limit, right? Okay, which means this L, the limit of f plus the limit of g, is the limit of f plus g. We did not give exact proof last time. Okay, I said we will prove something. So here I will going to prove this. I only prove this one rule. Okay, and for all other rules is very similar as this one. You can go to prove by yourself. How to? Epsilon delta language, the very, very accurate language in mathematics. Let me go to find. So how to do? Now, 2 steps. Okay, the first step, explore this one. Explore the definition or the inequality to find the data on a scrap paper. Okay, another paper. The second step, write down all the steps. So let me see. Wait. It's not difficult. Okay, so for these questions, but you need to pay attention. So all we need to do is find out what is the data. Of course, is the same. Explore this to find what is data. Of course, what is A? Let me go to see. A. No, we don't know. A is just the A. Okay, A is just the A because we have a general A, and the L is just the L. F is F. Let me see a little bit. It's not this. This time F is going to F plus G. So I have to change. I have to change this. Okay. Given any epsilon greater than 0, find the data so that if X is going to the A is the data's neighborhood of A, then so we have this. Okay. We have the absolute of Fx plus Gx. This is our function minus this minus L plus M less than epsilon. Okay, so it's this one. Now all we need to do is from here going to find what is data. Okay, so we're going to here to find what is data. So is similar as the last one. Okay, so we need to find data 1 and data 2 and then to pick the minimal data. Okay, but how do you explore this? So can you see our condition? We have F with the limit L, G with the limit M. So F, L, you need to put them together. G and M to put them together. Okay, so we do this. We just switch the terms. We compound. Can we see? We look at the left. Okay, so the left. Okay, I directly look at the left. The left is here is Fx minus L. Okay, plus Gx minus M. Okay, and the absolute value. Do you remember triangle identity we have? Okay, if A plus B, the absolute value should be less than or equal to, right? Absolute value of A plus the absolute value of B. I mean, so we can break it down into this bigger term into 2. So this should be less than. The first term is F minus L. The second term B is G minus M. Okay, good. We break it down into 2. The first is Fx minus L. Plus the second is Gx minus M. Now you know what we can do, right? Okay, so our purpose is less than epsilon. This plus this less than epsilon. How to make this? We can make the first term less than half of epsilon. The second term also less than half of epsilon. Put them together is epsilon. Okay, so what does it mean? We can do this now. We can make this the first term less than epsilon over 2. The second term also less than epsilon over 2. But why? Why we can make this less than epsilon over 2? Do you remember? F has limit L. F can be arbitrarily close to L. Okay, which means if we use epsilon data language for this small number, we can find the data 1. Can you see this? I put it here. We have data 1. Okay, if X is going to the data 1's neighborhood of A, and the first term was less than any number. Okay, right? So we can make this less than half of epsilon by data 1. The same we can by data 2. Okay, because we have the limit G is M. So for any epsilon over 2, for any number, okay, we can pick or exist data 2. If x going to the delta 2's neighborhood of A, and g minus m should be less than any number, right? So this can be arbitrarily close to m by taking delta 2. Okay, now you know how to do. We want the first term is true. We want the second term true is also true. All we need to do is make delta equals the minimum of delta 1 and delta 2, right? That does make sense. So now is the same as the first one, right? Okay, and the first true is for delta 1. The second true is for delta 2. If we want both satisfied at the same time, to pick the minimum delta. Okay, so if we pick the minimum delta, now what do we have? So the first term is less than. Okay, so can we see less than epsilon over 2? The second term is also less than epsilon over 2. Add them together is epsilon. Can you see? So we can make this is true. Okay, how to find the minimum of delta 1 and the delta 2. So here the idea is still the same as the first one. Now all we need to do is just make our sentence true. Okay, so we make all this stuff on the paper. Okay, so now it's easy. A little bit of challenge, right? Okay, but please be pay attention. Okay, so now all we need to do is write down all the stuff we did, but how? So this time is a little bit. Okay, we need to choose delta equal this. All we need to do. So the first you define what is delta 1. The second you need to define what is delta 2, and then you can define. Otherwise you can define delta. Otherwise you don't know how to define delta. Okay, how to define delta 1? Because the limit of f is L. Okay, let me write down. So now is this. So first still we need to give any epsilon greater than 0 to remember this, and then we choose delta. Okay, but before we choose delta, we need to define what is delta 1. So define delta 1 from f. The limit is L. Okay, so I have to write down stuff. Okay, since the limit x approach A, f x equals L. Okay, because of this. So for the number epsilon over 2 greater than 0, this is a number. Any number f can goes to this number of a neighborhood of L, right? Okay, which means exist. This is the symbol for exist in mathematics. Okay, exist delta 1 greater than 0. Let me write down this for you. This just says is just exist means exist in mathematics. For this small number, we can find the delta 1. Okay, and such that, right? So so you know this is such that. Okay. So we can simplify something by using this symbol, such that if x minus a, the absolute value, less than delta 1, which means if x go into the delta 1's neighborhood, okay, and then f will go into the epsilon over 2's neighborhood of L, then okay, the distance between f and L is less than epsilon over 2. Is this true? Yeah, this is what we did, right? Because the limit equals L, give any number, you can find the delta such that x going to the delta's neighborhood and the f going to this number's neighborhood of L. That's the epsilon delta language. Don't worry, here we pick epsilon over 2 is good, okay? You can pick any number, okay, no matter what number. So the same, we define delta 2 for g, right? Okay, now I will write down. Since the limit x approach a, g x equals L. Okay, now the same. we for epsilon over 2, any number, right, greater than 0, we can find or exist that there are 2 greater than 0, and such that if x going to delta 2's neighborhood of A, and then okay, and gx go into minus m. Okay, oh no, sorry, so here is not L, here is M. Okay, here is M. So minus M should be less than epsilon over 2. Okay, so you know the second step is similar as the first step. So what we did, we define what is delta 1, we define what is delta 2. So now what we can do, we can define what is delta, right? Delta is the minimum of delta 1 and the delta 2. So this is true, this is also true. Can you see? This is for delta 1, this is for delta 2. If we define delta is the minimum, so these both are true, is what we did. This is the first, this is the second. If we define the minimum is if define delta is the minimum of delta 1 and the delta 2, so this is true and this is true at the same time. That's all we need. So let me write down another stuff. So the last so here all we need to do is choose, right? Let me choose what is the delta. The delta is do you remember, the minimum of delta 1 and the delta 2. Okay, this is the most important. Okay, remember, now we can define, because you know what is delta 1, what is delta 2, right? So we can define what is delta, and then now make the statement true. What is the statement? Statement is if x minus A greater than 0, less than delta, then you know what is. If x is going to the delta neighborhood of A, and then can we see if the last, okay, if this is true, okay, the statement is true. It is true, right? So we explode it, okay, but we need to write it down. So we make it clear. Is what? Is fx plus gx minus L plus M absolute value. Do you remember? All we need to do now is to make this is less than epsilon, which means f plus g go into the epsilon neighborhood of L plus M. We need to prove, okay? And you know, the first we merge f and L together. So fx minus L plus gx sorry, minus M. Okay, we just put the like term together because f is linked to L, g is linked to M, and now it's a triangle identity, right? Okay, and triangle identity, okay, or inequality, and so this is one term, this is another term. A plus B, put the absolute value is less than or equal to the first term, okay, absolute value, plus the second term. This is a triangle identity. If we have this now, can you see, go back, the first is already, can you see this, f minus 0 is already less than epsilon over 2. This is less than epsilon over 2. This is less than epsilon over 2. So what do we have? We have this is less than epsilon over 2 plus epsilon over 2. Why? Because this delta is the minimum. So both statements are true. Okay, I hope that makes sense to you. And then do calculation, this get epsilon. Good. See, if x is going to the delta neighborhood of A, we already make f plus g going to the Aboriginal neighborhood of L plus M. So what do we get? So we get the conclusion. So by Epsilon-Delta definition, what do we have? We have the limit of this is here, right? Okay, good. Let me put down. So we have the limit. I guess put a put f(x) plus gx. See, this is the bigger functions equals L plus M equals L plus M. Okay, L is the limit of f, M is the limit of g. This is what it is, the sum law. Okay, yeah, that's all. Thank you.